All right. Well, here is a little tutorial on how to do some math problems for our upcoming semester test. This is number 13, our review assignment. It asks us to find a point on a graph of this function and where it's closest to the point 2, 0. Now, first off, when you use strategy to figure this problem out, you probably want to first graph this one. Okay, so I'm going to graph because we're going to find a point that's on the graph of this function being a quadratic. It is shifted up 3 units, so we have a parabola looking like so. Now from here, we have another point which is over at 2, 0, so 1, 2, 0. And we are trying to find a point, let's take this right here, all right, that is starting at this point and is somewhere along this line right there. So this point right here, if you move it around, can be at any one of these values on that curve. Okay, so it's moving around like so. Now our job is to find out what is the minimum or closest to the point. So we want to find, if you think about it, closest means a minimum distance. Okay, a minimum distance. Well, a minimum distance from these 2 points. So we have one point, which we know is going to be 2, 0. And we have another point somewhere on this graph that's going to be, well, our x value and our y value. Now, we're going to put y in terms of x. So it's going to be y and x squared plus 3. So that's our other point. Now, with these 2 points, what we can do is we need to find the minimum distance. So how do you find the distance between 2 points? You should ask yourself, well, obviously, you need to use the distance formula. So or we can create our little our 90-degree triangle. But we're going to use the distance formula. Take your x's over there, subtract them, square them, put your hangy thingy there. That's the little song that I sing. I created. You can check out another video on the lyrics of that puppy. But we have this as our distance formula problem. So we take our values, our x's. So we take x minus our other x, which is 2. We'll square that. We're going to add that to our next value, which is x squared plus 3 minus 0 there. Square that, square root, and we have this. We simplify this, and we have x minus 2 squared plus the quantity x squared plus 3 squared square root. Now, one thing, if you want to use calculus, we can find the derivative of this, find the critical points, and then that will give us our minimum distance. Now, to make this a little bit easier for us, this is a little bit more complex problem, is we can actually go on, because we're looking for a point. So let's go to our calculators. I'm going to take mine out right here. And we're going to enter this into our calculator. So I'm going to take mine right here. I'll put this to the side. Move this over a little bit. Okay, see this? So we're going to input this into our calculator. So y equals, we're going to take the square root, and we'll put in here x minus 2. Oops, let's go back. There we go. That, and we're going to square it. What is going on here? Love technology, don't you? Alright, there we go. And then let's square this. Let's add that to quantity x squared plus 3, quantity squared. And we can graph this to find out what it looks like. We have a graph that looks like this. Alright, if you want to go zoom 6, you can get a standard window. But we're looking for a minimum value here. And we can see that we do have a minimum value, which is located right around this location. All right, so what we're going to do is we're going to find that minimum. And so let's go and go second calculate. And we'll go down to minimum. And I'm going to go to the left side of where that minimum was. Press enter. Go to the right side of where that will be. Press enter again. And what we have is going to be approximately x equals x equals 0.279. Now, that right there is the x value for our point. Now, we also need to find out what the y value is because we're trying to figure out what is the closest point on this graph. So, going back to our calculator, obviously it's not a nice number. X being the x value, y, in this case, if you think about it, this is actually the minimum distance that we would find. So we don't want that. We actually want to find what the y value would be. So we're actually going to take this, and we can go over here, and we're going to put in, and we'll get a estimated answer. Go plus 3. I'm going to go to my table, and I'm going to insert, just so you know, I go at table set, and I'm going to put this at ask, my independent variable. Ask that value. So go to my table. I'm going to look at y2. I'm going to put in 0.279, and obviously there's going to be a little bit error here, but we get an approximated other value. Y equals 3.078, I believe it was. So check this out again. Not sure. And yes, that is what it is. We're under 3 decimal places. So that right here is going to be our closest point. Okay, this is the x value, all right, of this point right here, along with our y value, which will be right there. And that is how we determine, all right, and find the point of the graph, the closest point to 2, 0. Enjoy, and we'll try to do another one in a little bit.